the insertion sort of. Okay, so this code is the insertion sort code. Okay, so I wrote this, I wrote it first thinking, okay, I have the algorithm and I will do this, okay? And what I have here is that aj minus 1 is the assigned target. So it's sort of like I'm trying to insert the ith element into the right place, and I kind of do this, okay? Now, let me show you, I call this buggy, but I didn't know that until I wrote it and run it, and then realized that it's really not sorting it, okay? But I want to show you how it will work in practice if I have the buggy code. So here's my insertion sort here. That's the selection sort, here's the insertion sort. Okay, in that code I had j minus 1. Okay, so that's all. This is the only thing I changed, j to j minus 1. That's what I had when I wrote the procedure first. This can happen to anyone, okay? And let's suppose that I now try to use insertion sort. So this shows you the subtle things that can, so suppose I create a random array and use the insertion sort. Okay, so I'm going to create a random array of n things, which I will provide as a command line argument, and then sort it and print it to see if it actually sorted it. Okay, so let me show you how that's going to work, and let's just do here. Okay, so this is running with 10 things. Okay, so notice that it gave me error, right? Array index out of bounds error. Okay, so to figure this out, because you really don't know what's going on here anymore. Let's say so one way I can debug this is to make the array, rather than making it random, let's just make it something we know, right? Like this one here, 94 and 90, right? So instead of A, instead of B, I will give A. Okay, so I will take some control over what's happening, because with the random array, I might not be able to figure out what's wrong with my insertion sort. Okay, so I change that. Now I know exactly what the array is. I will do that, and then I do this. Still out of bounds, right? And even if I test with just a single element, it's out of bounds. Okay, so now, what would you do at this point? Right? You're not going to jump off the bridge, right? You're not going to do that, right? I hope you won't do that. But it's very frustrating, right? Yeah? Yeah, so you have to really, the only way to figure this out now, because I can't use examples anymore. Your index out of bounds, index out of bounds. Right? The only way to figure this out is to really take your array and walk through the code to see where the problem is. But it turns out that the problem is here. It's a subtle error, but it really causes a lot of problems, right? So if I had changed this, if this was j, in other words, I was trying to assign it to a j minus 1. Most likely, it's going out of bounds, right? Because j minus 1 could be minus 1 if j is 1, if j is 0. Okay? But if I have a j, so you can see that in the array, I will get out of the array when j is 0. Right? This one says j is greater than or equal to 1, so I may leave the array when j is 0. I mean, the loop. And so if j is 0, this would create a problem. All right, so let me see whether that's the fix. Right? So, but I couldn't find it unless I kind of walk through my code. Because now if I do, let's put some numbers here so that it's going to be more interesting. Some random numbers, I don't know. Okay, so that's the array that I want to sort. Only thing I did was to change that. Now it's sorted. right? So only thing I had changed was from -1 to just 1. I think if you have index out of bounds, you always know that there's something going on with your loop bounds, okay? And obviously now I can do it for, now if I'm convinced that it's working for the small thing, I should be checking it for large ones, right? So I will create a random array. So in this case, what I'm going to do is I'm going to do this, and then this is an array of size 10. Notice that it got sorted. Okay, so here's a random array. I mean, I'm not showing you the original array, but here's the array after it got sorted. Okay, so every time I can run a few times and make sure that it's actually sorting this random array. Okay, so using the insertion sort. So the next thing I try to do is to compare. Remember we did like a sort of a comparison of big O comparison here, right? In the big O comparison, the insertion sort kind of came out okay when it's sorted. In fact, you know, in real life, most data sets are almost sorted, and they're very friendly to the insertion sort. Okay, if you have a data set, it doesn't have to be sorted completely, but the life is such that things that are equal appear together, right, most of the time. Right, they cluster together. All right, so we can actually take a look at it. You know, here I'm timing insertion sort and the selection sort. So let me try to compile this again. So now I'm going to compare insertion sort and selection sort for 10 things. Actually, let me just not print the array because that's going to be a pain as we go to large things. Right? Let me also not do that. So I'm just going to compare the two arrays. All right. Okay, so this is the timing for 10. This is if I compare insertion sort and selection sort for 100 things. Now notice the selection sort is a little bit slower now. Right? It took 1 millisecond. Let's make it 1,000. So now the selection sort is better. Right? Remember, I'm working with random things. All right? So maybe the array wasn't very friendly towards the insertion sort. It might have been kind of, you know, reversely sorted or something. But if I go to like 10,000, so now the selection sort is a little bit slower, right? 17 seconds. If I go to like 10,000, no, that's not 10,000, it's 100,000, right? Okay, now I'm getting times like 856 milliseconds and 1000 milliseconds, right? So the selection sort is slower. If I go to like what is that number? Is that 6 zeros? A million, right? So if I do a million, okay, we're going to be here for a while. Right? We're going to be here for a while. You guys ready to stay here for a while? No? Or you want to go home? Huh? Okay, but let's do an estimate. Okay. Now when the data size was okay, so this is what we know. Okay, when the data size was 100,000, 10 to the 5. Insertion took 856 milliseconds. How much is that? 1,000 milliseconds is 1 second, right? So it's like 0.8 seconds. 0.8 seconds, and the selection took like 1 second, right? Okay? 1 second, right? But then we went to this. Didn't look like a big change, but I was hacking into my machine, huh?
Obama.
Okay. All right, could be, all right. So, so here's the point, okay? Both of these algorithms are n squared. If you have an n squared algorithm, if you make the data tenfold, okay, tenfold, and it will increase the time by 100-fold. Okay? So your estimation of this should be around what? 80 seconds. Did it come back yet? No?
Yeah.
Oh, yeah, it did. 80 seconds, not bad, right? What is this one?